We are going to be simplifying radicals. We have to check if we have the same index. In this case, we have an index of 2. We have an index of 2, so it's okay that we kind of combine both radicals. So I'm going to rewrite this. Square root 54 divided by 2. And we have x to the fifth divided by x squared. And then we have y to the third divided by y. Remember that when we have numbers at the same base, like we do with x and y, we're going to go ahead and subtract the exponents. So 54 divided by 2 is 27. X to the fifth divided by x to the second, or x squared, is x to the third power. 5 minus 2 is 3. Now we have y to the third power divided by y, which gives you y squared. Next, we're going to go ahead and we're going to use our understanding of the index to figure out what are our pairs, so we can find the square root of that number. So I'm going to do a factor tree, prime factorization tree. So we have 3 times 9, and 9 we have 3 times 3. X cubed, we have x times x times x. And we have y squared, which is y times y. And what we're looking for are groups of 2, so that's our index. So we have these 2, which is a group of 2. This here is a group of 2. And this here is a group of 2. By us finding the groups, we know that we can find the square root of 3 squared, we can find the square root of x squared, and we can find the square root of y squared. Now, unfortunately, we have this 3 here, and we have these x. So you might be asking yourself, what do we do with that? We're going to leave it in the radical. We will be leaving 3 and x in the radical. So I'm going to write this down. So we have 3, the square root of 9 is 3. Square root of x squared is x. The square root of y squared is y. Then we have the radical. And so the 3 and the x will stay in the radical. So this is going to be simplified to 3xy times the square root of 3x. Okay, we notice that we're dealing with the fourth root, or the index of 4. What I'm going to do is I'm going to simplify what's inside the root. So in this case, we have the fourth root, and we're going to go ahead and divide 343 divided by 3, which gives us 81. Now you notice that if we did 3 minus 7, that would give us a negative 4. So that requires us to put the variable in the denominator. So we have k to the fourth. What I'm going to do is I'm going to do the prime factorization tree for 81. So we have 9 times 9. We have 3 times 3 times 3 times 3. You notice there's 4 here, 4 3s. So I can get the fourth root of 81. So the fourth root of 81 is just 3. And the fourth root of k to the 4 is just k. So this will simplify to 3 divided by k.